So thanks for joining us here this morning. I'm in Fort St. John at a hockey tournament, and fortunately I found a hotel that has really good internet access, so hopefully this will go very smoothly. And Dean is in our headquarters in Surrey, BC. So good morning, Dean.
Good morning, Don.
And okay, so we're going to talk about big data, and in particular how FME plays into big data, and we'll talk about cloud infrastructure and that sort of thing as well. Okay, so here are the presenters. Good-looking couple of people there. And my name's Don Murray, and I'm here with Dean Hintz, and you can see our Twitter handles there. So please do follow us.
Yeah, and please do ask questions. We'll try to answer what we can during the session, but if there's things there that, there's bound to be things that require a bit of research, so we might get back to you a little bit later on those.
Yeah, and Mark Stokes is going to help us with this, and Dean touched on a very good thing. Our big data story at SAFE is definitely a work in progress, so everything you're going to see here today really is stuff that Dean and I have been building, I guess, as part of our research / labby kind of stuff at SAFE, and so it's we're very excited about what's going on here, but we're not going to pretend we have all the answers, but this is a very exciting area, and we want to share it with folks and begin a conversation. So if any of you have things you're working with or big data or interested, we would love to work with you and learn more and share with you what we've learned. So, yeah. So the agenda, very quickly, what is big data? Some big data challenges, how FME, FME cloud and things like that work with big data. And then we're going to look at two very different databases as far as big data goes, and we chose these two databases because they're very different than other databases that FME has worked with. And so we wanted to, to cover those rather than just say more traditional databases that are also hosted in the cloud and can store big data. Okay. So SAFE software. So what do we do? I think only 2 slides here, Dean. So go to our website. You're going to see connect, transform, and automate, and that's really, in 3 words defines what we do. We connect to many different data sources. They could be files, they could be databases, they could be applications, they could be mobile devices, they could be sensors, they could be anything that produces data. And you can connect to as many of these as you need to, as you want. You can see in the background screen there, you can see even Twitter, so you can consume data from Twitter, you can send data to Twitter. And the key is once you bring these data sources together, what do you want to do with it? How do you transform it? How do you manipulate it in order to restructure it or help you make better decisions? And of course, at the end of the day, what's any tool about? Automation, so that then you can set up these processes once and have them triggered by events or run in a part of a schedule, or whenever a user clicks on a map or a user clicks on a website or something arrives from a mobile device. And that's, in a nutshell, what we do. We have 3 products. We have a desktop product, which is where all the authoring begins. You can also run it there, so everything we're going to run this morning, we're going to be running on our desktops, even though they really belong to run in a production environment on server or cloud. And at the end of the day, it's all about harmony. We create harmony between data and applications. Isn't that right, Dean?
That's right, although we will try not to create harmony by singing today. I think Dale's better at that.
That's right, a 2-part harmony. Yeah, that would, we'd watch the numbers fall off the webinar very, very, very quickly. So we'll open with a quick poll. And Dean, do you want to launch that poll?
Sure, just a sec.
Okay, so the poll is, which version of FME are you using? Okay. And yeah, so launch that poll.
Yeah, it should be up.
Can't see it. Okay, there it is, and the answers are FME 2011 or older, FME 2012, 2013, 2014, or I am not an FME user yet. Okay, you'll notice that we put the word yet in the middle of that question. So anyway, so here they come. So wow, 37% of people are on the latest FME 2014.
Wow.
25% or 2013. Yeah, yeah.
Must be a pretty good release, Don.
Must be, yeah.
Yeah.
And SP1's just around the corner, about the end of March, my understanding. And a little over 25% are not an FME user. So thank you so much for coming this morning, and we're really glad that you were able to take the time to join us, and hopefully you'll learn what you came here for. And if not, please let us know what you'd like to know, and we'd be happy to engage you further. So there we go. Okay, so if you're new to FME, there's a couple places you can go. We have a weekly webinar. It's done by somebody from Pro Services. Often it's Mark Stokes, who's joined us today for questions, and also usually Craig Vernon, who is always a crowd pleaser. So you'll have a lot of fun, and also learn a bit about FME as a first, sort of a first step. And there's also a Getting Started page on FME. So there you go. Okay, so what about big data? So what is it?
Yeah, what is it, Don? What is all this? What's the big deal about big data?
This is showing you need big databases, and this is showing sensors and music and traffic and anything like that. So here we go again. So what is it? So basically, it's all this kind of in today's world, data is coming from everywhere. It's coming from social media, XML documents, traffic sensors, airborne sensors, music, video, maps, and everything. So that's where the data is coming from. So that's that one there. One thing about big data, well, that didn't show up well, but oh well, is big data needs big resources. So you need big data stores, you need big processing power, and you need big bandwidth. And cloud technology. When we start talking about cloud technology is a natural fit for this. If you're doing big data in the traditional way, what you're going to need to do is you would need to purchase all that equipment. So you would have to, sort of say, okay, this is the size of the system I'm going to need. Then you'd have to buy all that. You'd have to set up all your infrastructure, and that would be really, really expensive. So, and then of course, until you hit a capacity, by definition, you'd be over capacity. So you'd have all that hardware sitting there. Until you hit capacity, and then if it was really success and it kept growing, well, now you would have to go and buy additional hardware. You're always going to have to replacing hardware. You're going to need the staff to do it. And with the cloud, basically you just purchase what you pay as you go, and what you use is what you pay for. So you can see the examples I'll do today. We start very small, and then so you only pay a little bit, and then as you add more and more, you get bigger. So things like that. So the cloud and big data is really a natural fit. We talk about often at SAFE, the thing that enabled us to get started was we were able to take a very inexpensive desktop machine and develop applications. If we had initially started with a big server thing, we would never got started, because at the beginning we didn't have the funding. And now with the cloud, what it really does is democratizes or makes all that technology available, where even the company with the smallest of budgets or a person with the smallest of budgets can start to build these big data solutions, cloud-based, and as they grow, they just have the incremental costs that grow along with it. So, yeah. Okay, big data and FME. We talk about big data as a new classification for FME. That's not entirely true, in the sense that big data can store all the other types of data. So you're going to see here we're going to use big data to store, some GIS data, CAD data, raster, could store point cloud, 3D, XML, BIM, pretty much any type of data. From FME standpoint, these new data stores are no different than any other data to FME. FME is just connects to anything, and so these big databases is just yet another connection to FME, and so it makes it really, really easy to. The whole goal is to make it easy, so you don't even have to think about what you're doing when you're moving data in and out of these big data stores. So, and again, FME Cloud is a natural fit. FME, of course, likes to be close to the data. So if you're building your big data store in the cloud, then it's a natural that use FME Cloud because you're going to get big benefits on just the communication side of things, and plus then you can also scale, adding many processors or many FME workspaces running in parallel, distributed, throughout the cloud to load the data in or query the data out to support many users for this big data. So, yeah.
So, Don, do you have to do big data in the cloud?
Absolutely not. So, if you're doing big data, you can do big data on the cloud or big data on premises. If you're on premise, so like you're going to show MarkLogic, and in your case, it is on premise. So, if you have your database on premise, then you want your FME on premise. For sure, the thing about cloud versus on premise is both of them are fast, both of them are good, but you don't want to be moving the data back and forth. So it'd be really bad to have all your data in the cloud and all your FME on premise, or vice versa. Now they could work, but you're going to be, the communication costs both for the infrastructure and the amount of data move is going to be the determining factor.
Yeah, the expensive bit is moving between those. So trying to initially load all your data up into the cloud, don't expect that to happen super fast. Once you're in the cloud, then everything's pretty quick.
Yeah. So this slide just shows some of the big data support we have in FME right now. So we're not going to go through them all because you can click and find out yourself. Amazon RDS, essentially what this is Amazon manages SQL databases for you. I wrote a blog article on Amazon RDS with PostGIS, but it also supports SQL Server and Oracle. And we're not going to, that's all we're going to talk about on that one. It's a petabyte database. Oh, no, it's not. It's just a very large database. Amazon DynamoDB, we're going to be using this one today. And this is a database that can be as big as you want. There's no limit on it. It's a NoSQL database. And again, click on that. We'll talk a little bit more about that. Amazon Redshift, this is a petabyte scale SQL database that folks like NASA use, for example. And again, we have support for this. And this looks like Postgres. So it's got full SQL based on Postgres. So that's very interesting there. And that one's a petabyte. Google BigQuery, again, FME supports that. That's a very super fast database for queries. Interesting, the tables are append only. So again, in many of these cases, to get performance, they've taken, you can't have your cake and eat it too. There's always trade-offs. So what Google's done with BigQuery has made this very super fast append-only tables. And there's many workflows where you're only adding data. You're not actually throwing things away. Like you could imagine the database of all past tweets. Well, you're not going to go back in and delete stuff. You just want to record things very quickly and then be able to query them. So that's very interesting. Amazon S3, we use that a lot at SAFE, and we're going to use that in our demo to show how we can upload any documents and spatially locate them and things like that. So that's basically, it kind of stands for Simple Storage Service. And you can essentially you can think of it as putting as many files as you want up there. And Dean's going to talk about MarkLogic, and that's a large XML-based database. And both Dean and I love XML. We sit in the XML quadrant, I guess, at SAFE, a triangle. It's kind of like the Bermuda Triangle, but it's at SAFE. It's got me, Dean, and Juan, and we form this triangle. And anybody knows who goes through there is going to probably be pummeled with XML questions before they're allowed to pass. So. Yeah,
we probably need to form some kind of XML addicts group, but it wouldn't be called XML Anonymous, I don't think.
That's right, and often we have our guard dog in the hall there, sitting in the middle. So, who's a golden retriever who lays in the middle of the hall. So there we go. Okay, so that's some of the things we support at FME.
Quick question, Don.
Okay, so now. Yep.
Just about that slide. What is meant by NoSQL? It's interesting to define.
We'll talk about. Basically, I mean, query language is not SQL, and generally, it's not organized into tables as you would think a normal database is. In the case of DynamoDB, you have tables, but every row can have different columns or columns that come and go, and the queries are very simple. Basically, in DynamoDB, you get a key, a hash key, and then you can get a range key. And the hash, if you just have a hash key, every key has to be different. If you have a hash key and a range key, then the hash range combination must be unique. So you can't have multiple things sharing the same key there. And you can have secondary indexes, but the queries are very, very, very simple. So yeah.
Right.
Okay. Okay. So
cool.
So now, okay, time for a poll, Dean. How are you currently working with big data? So you're going to launch that poll?
Sure. I just pull that up. There it goes.
There it is. Select one or more of the following. So currently, you'd say on-premise, cloud, Amazon Web Services, cloud, Google, cloud, other, or I'm not currently using big data. So okay. So
I suppose some people could have their own cloud, I suppose, eh?
Sure, yeah. Amazon supports something called VPC, Virtual Private Cloud, which essentially is your own private cloud based stored by Amazon. But yeah, you could have other. So yeah, so there we go. So no surprise, this is a very new area. So about 60% of the people aren't using cloud. So and then of course on-premise is 31%. So that's again, not too surprising. Cloud is new, big data is new. So you take the intersection of those two things, and yeah, so that's good. Okay, so back to the slide deck. Okay, so some of the big challenges, of course, are just loading data into big databases. If you have a ton of data and you need to load it in, with the, again, talking about the approach that I'm going to show here is the vision. The vision is you would just have many FMEs scattered throughout the cloud, just pushing data in as it comes, and then the underlying infrastructure of DynamoDB just sorts it all out. Many of the databases don't have spatial support. MarkLogic does. DynamoDB doesn't. So what I've had to do is build my own geohash-based spatial index to add spatial support to DynamoDB. There's an article on Dynamo presenting today here, also does points, very similar to their approach, but also does lines and polygons. So we're going to talk a little bit about that. Of course, once you get your data into these big databases, big data analysis is a huge issue. And again, if you want to do big grinding on these databases, you're going to again need a big scalable approach. And then, of course, querying. And we're making the distinction between big data analysis. We'll talk about analysis as you can think of it as anything you send to a big database is going to take a significant amount of grinding. So it might be some, Hadoop-based solution or some other thing where you got many engines grinding away to figure out something. So the time for an analysis could be in minutes to hours to days, okay? Whereas querying is also a challenge for these big databases, but querying generally we're thinking of very, very fast, from 1 second to, say under a minute responses to those. And of course, exporting data, you're not going to want to export your whole big database probably. With FME you could do it, but again, you'd want to have many engines doing it, but you want to just export the amount to share with other applications, as targeted as possible. Okay.
So it might be fair to say, Don, it might be fair to say that one of the big challenges, particularly for this audience, would be, there's some pretty snazzy tools out there for big data, but a lot of people will have legacy systems that don't easily integrate with big data, and that might be why that guy looks angry on that slide, is because if you've got ArcGIS, or you've got Oracle or other existing, relational-based infrastructures, doing the big data ETL and integrating your existing stuff with big data might be a bit rough at the beginning.
Yeah, exactly. So we're going to go through a couple demos here. The first one Dean's going to work through, and that's with MarkLogic. I think it's actually one word, isn't it, Dean?
Yeah, probably is, yeah.
Okay, yeah. Otherwise, we're going to introduce a guy named Mark, whose last name is Logic, but anyway.
We could just let Mark do this demo then.
That's right, and he's going to, yeah. And the second one I'll do, and it's on limitless spatial database, okay? So with that, I'm going to pass this over to Dean, so I better make you the presenter now, so let's see if I can do that. Okay. So you're probably seeing my slide here. Whoop, attendee. Okay. So Dean. Oh, Dean is a presenter. So there we go. Okay, take it away, Dean.
Okay, Don, you can see my screen there?
I can.
All right, very good. Okay, so just a couple words about MarkLogic and how that it interfaces or is supported by FME, and then I'll run through a few quick demos.
Perfect.
And looks like I've got it in one word here, MarkLogic. Okay, so what's interesting about MarkLogic and why did we choose to do some integration? Well, first off, it is a NoSQL database, so it does fall into that whole area of big data. You can basically store, it's great for storing sparse data sets, or you can put huge XML documents in there, and it's designed to handle that and index that and make it really powerful, easy to search. It is optimized for XML. It's not necessarily that XML is stored as text. Obviously, everything gets indexed, and there's some kind of binary sort of serialization that happens on load. But the whole structure of the XML is preserved in terms of the logic of how it's stored. So any node within that XML. Thing. Yeah, it is. It's awesome.
Even I love XML. Yeah.
Yeah. So basically, when you load it, you just point the XML at the REST endpoint, and it just goes into the database as is. And it's just as easy to get it straight out. You can stream the XML straight back out. So the whole idea of having a tool like that to build web services on top, you don't have to worry about complex schema transformations to and from relational just to provide a web service. So that's something we're definitely going to be doing more experimentation with. Yeah, it has powerful search and analysis capabilities, so doing some relatedness kind of queries about which element is related to some other element, and it even comes with some degree, somewhat, a bit limited, but it does have some native spatial support. So it can recognize point locations within, let's say, GML, and use that for spatial analysis. And finally, you can deploy it on Hadoop on an HDFS.
Perfect.
So why FME and MarkLogic? Well, it's a natural fit because we're really good at converting XML and GML. So we can convert from a GIS or CAD data into XML and then load that into MarkLogic, and we can do the reverse. Sure. We can read the XML.
Sure. BIM data too. How about BIM data?
Yeah, absolutely. Like some.
So if I have Revit data, I could convert it into, say, City GML and then put it in if I wanted.
Yeah, that'd be a great application. So yeah, I did a presentation recently in the DC area where we were going from Revit to City GML, and so that could just as easily have gone from Revit to City GML and then into MarkLogic, and then use MarkLogic to do that those kind of queries.
Yeah. And then another format, XML format, another XML format I'm excited about, of course, is AIXM, which is the aeronautical one. So you could imagine a big aeronautical database in AIXM stored right within MarkLogic too.
Yeah, you could have, that's a good example. So you could have both the baseline data, like the world airports, which you're going to see in a minute, or infrastructure or airspaces around the world. And you could have live data, so let's say notices to airmen and stuff. That could all be in there as well. So that's a good example. Another one might be, the EU Inspire. So there's all that Inspire data is all GML. That you could load that up into MarkLogic. Yeah. So that's basically, why it's a good fit is because FME is great at doing that GIS/XML ETL. And so that's a natural tool to load into and export from MarkLogic.
Good.
So the first demo I'm going to look at is how do we get data into MarkLogic, and so there's both about the conversion to GML and also a REST, the REST call to put it in. And let me just pull up my first. Just to begin with, for context, yeah, okay, my first workspace. Yeah, here we have a workspace which basically all we're going to do is we're going to read an XML data set and load it into MarkLogic, and here's basically the expression we're going to use is just this, the MarkLogic server, and then we just need a URI, a unique URI, to assign to the XML document when we load it, and that's pretty much all there's to it. And then the loading is done by this HTTP uploader. I could have wrapped this up in a custom transformer and made it like a sort of a custom writer, but at this point I thought I'd just let you guys see how this thing worked. So we just have to basically load the XML data and then do an HTTP put to MarkLogic. And just to show how this works, well, to show exactly what we're loading, first off, I'll just go into that folder. I'm going to be loading the Chicago O'Hare data set, and we can look at that in Notepad and just say, okay, this is XML. You guys have seen XML before. And this is AIXM, as you can see from the namespace declarations up here.
Yep. Okay,
so let's go ahead and load something. I'm going to hit run, and I'll change this to be 18th. So you can say AIXM Chicago March 18th. I'll just copy that so I can easily find it later. And I've got my name in there. Oh, better set the load time. I've got a timestamp in there as well. Transformer. So it's good to capture as many keys as possible when we're doing this so that it makes it easier to search for this stuff later. That red line there is just some kind of a encoding thing I haven't quite tweaked yet. And there's the that REST call to load. So you can see the hash there for the ID of what's getting loaded.
Yeah, this is great. And another area at SAFE where we're spending a lot of time right now is coming up with really nice REST interfaces from within Workbench. So this is also good from that standpoint, Dean, just to show where we are now, and then we'll be able to talk about where we'll be later at future days.
So that's already there, and I'm going to go over to my MarkLogic server, and you can see these are the data sets. I've got about 30,000 odd XML documents in there. And what I should be able to do just to make sure that this thing did get loaded, I'm going to run, just from the MarkLogic side, I'll just run this query and show that, yes, this in fact did get loaded. And you can see there's that hash ending in 3075. Hopefully that's the same as what yeah, that's the same document I loaded earlier. And then the flip side, just to show that we can get data out of here, this is my extract tool, which I'll run in a second. And all that does is it takes a request, builds a request using a string concatenator. And so this is there's two parts to this query side of it. One is we actually have to find that ID. So we query on the data set name, or in this case it's Chicago, so we'll say something about Chicago. It sends that to MarkLogic and says, give me the URI for Chicago. Then once I get that URI, I also have to build up, okay, give me the data set or the document associated with that URI. So that's what this expression here does. Builds up that request. And then all we're doing is streaming out that data. So let's go ahead and do that. So we just change this to be March 18. So where comment equals March 18, give me that data set, and I'll go ahead and run that. And then to prove that worked, as you can see, it's first do the find, and once we find it, then we need to retrieve the document associated with that ID. So I'll go over there to that directory and grab that data set when it's done.
And you're running all this just on your local laptop, aren't you, Dean?
Yeah. So this would all be a fair bit faster if if I was running this stuff in the cloud. But as you can see, it's relatively quick, even for that.
Yeah, it's great.
So we're using our AXM5 reader. We of course have a new AXM5 writer as well as of 2014. Right here, we're just reading. And so all I'm proving here is that, in fact, we can take that. This is the XML that came straight out of that server, and I'm just proving that we didn't have to do anything special to preserve the structure. If we didn't have the structure right, we wouldn't be able to read it with our AXM5 reader. So it'll just take a second to come up.
Okay.
And see if there's anything. There is I am using this fragmenter to pull out the XML body from the response message. And I did some validation there before I bothered writing it, just to make sure nothing got corrupted.
Great.
So this will come up in another second or two. So that's basically a round trip, just with XML.
Yep.
And here's our Chicago O'Hare Airport with a little bit of a background map. And so you can see the runways, and you can see also that once this thing's finished doing the background maps, you can see that structure, that complex data structure, is all preserved. So that just went. I just uploaded that to MarkLogic and pulled it back out. Everything's preserved, and so we've got essentially a place to store XML-based geospatial data.
Yep. Yeah.
And
and of course you could take that data and go out to KML if you wanted to as well, and see Google Earth or Google Maps or whatever you want. Yeah. So you can pick whatever, or to ArcGIS or whatever. Yeah. Good. Okay. So what's next?
So this is the basic workflow. Now what I want to do next is actually take some GIS data and then put that in and pull it out and show what that looks like. Okay. So this is the workflow of what loading GIS data looks like. And the thing to highlight here is that we're going to do this coordinate extraction. So we actually have to convert the GIS data into, in this case, I'm still going to work with, sticking with the same theme, still working with AXM data. So just to get a clue of a feel for what we're working with here, I'm going to zoom into the west coast of BC, where we are today, and hopefully my Google Earth display works okay. It's kind of a little bit choppy on GoToMeeting, but so there's the data I'm going to look for, and you'll notice that it has this thing called location indicator ICAO of CYVR. So that's the code I'm going to look for to find this. So this is the data in my GIS at this point. I'm actually going to be using an SDF data store, but I just wanted to visualize this as KML. So this is the world's airports. There's about 35,000 airports here, and that's all been loaded into my MarkLogic database. And so to see what that actually looked like, I don't have time in this demo to do the load itself, because getting all that data in, it does take a little bit of time. So basically, this is the workspace that I use to load it. And like I said, first of all, we had to extract, so we had to convert that GIS data from the SDF. This is essentially an FDO database. And so I use this templater to build up the AXM records. And the key point here is there's the GML position. So this is the AXM elevated point is that GML geometry that we're building up. And I could have used a GML geometry extractor as well, but I needed to capture the complex AXM schema in this particular case. And then I have to actually build the update message. So this is the message for posting that document to MarkLogic, and then I basically just I have a templater for the update message, And so here the key part is, okay, I have a XML attribute that I built with a previous templater, which has the GML AXM data, and then I have some specific fields around the airport code. So there's that ICO code that we're storing, exposing that as a key.
Good. Okay.
So that's that. And then just to execute that, I have another what I call a query MarkLogic database, which is much the same as the one you saw before. And all it does is just going to, instead of querying on the data set name, I'm going to query on the value, this ICOA value. So I stored that airport code in a field called name.
Okay.
But I'm going to take this a step further. Instead of doing this just by running a workspace, I'm actually going to do that using, I've published this to my FME server. And so to show you first how that works, or we'll test it, see if it's working or not. And all I'm doing is pasting that URL into my browser and querying, okay, give me the data from the MarkLogic database for YVR. That's actually going to do two queries against MarkLogic, right? That's basically going to say, find me the URI code for YVR and then get me the data for it. And you can see there's our location there at 49 North, 123 East. So that's that data. And another way of doing that is I can just go ahead and open a reader in Data Inspector and say YVR. So I'm just putting that URL directly into the Data Inspector. So that's actually pointing at FME server, which in turn is talking to MarkLogic.
Right.
And,
very good. Very good.
And I'll just pull up, while we're waiting for that, I'll just pull up the, I had an overview slide for that. Okay. So that's basically what that looks like. So basically the request comes into FME server. FME server parses that and fires off, passes that query on to MarkLogic. MarkLogic provides the response in terms of the document ID. FME takes the document ID, retrieves the XML, and then streams that XML back to the client. It could just as easily, as you pointed out earlier, Don, convert that XML into some other GIS data and stream that back to the client.
Okay, good, good.
So
I think you have about 5 minutes left for your demos.
Well, this is basically my last demo here. So
is it?
While
okay,
I'm waiting for that, while I'm waiting for that to come up, I'll just basically make the point that yeah, we could convert. You could just as easily convert this to yeah, JSON, KML, GML, anything that that works. Typically, you know, we're doing stuff over the web, so it might be a web-friendly format. But I guess in theory, yeah, we could convert it to a shapefile and then zip that up and provide that as a download. So really, the sky's the limit. So there's the data. You can see we're zooming in on Vancouver here. We got that background maps, and let's look for that ICOA code. And yeah, sure enough, we've got YVR there, Vancouver International. So basically the round trip there is that we've loaded data. In this case, I loaded the world's airports into MarkLogic. So there's you know, 35,000 or more airports, and then essentially what I've done is made a web service. So all you've got to do is essentially, I think there's like YYZ is Toronto. So it's essentially a web service where you can query the location of any airport in the world, and it'll give you back the AXM, GML or XML for that data. I probably misspelled that, but anyway. Okay, so let me just see if I have another. Yeah, I did. There is something else that I've worked on. I don't have time to demo today, and that is an integration with ArcGIS. So basically, it's the same kind of data flow, but using FME to load data from ArcGIS server as a feature service. We convert that submit a request to MarkLogic, get the data back, convert that to Esri JSON, and then stream that to the ArcGIS server.
Yeah.
And then we can, of course, go the other way as well. So this is the workspace that I used to do that.
Yeah. Yeah.
Okay.
Yeah, good.
So I think that's, without further ado, I'll probably pass it back to you. And then if there's questions about the MarkLogic stuff, feel free to ask.
Perfect. Okay. Okay, so that takes us right up to here. Slideshow from current slide. Okay, so am I the presenter now? Yep, show my screen. Okay, so thanks, Dean. That's exciting. Obviously, within an hour, we can only touch on a few things. The second demo is we're going to use big data technology in the cloud, and in particular, we're going to use Amazon DynamoDB to build our spatial index and store some data, and also we're going to use Amazon Web Services, Amazon S3, as the container for all the rest of the data. So yeah, and we'll talk a little bit about Google Docs. Okay, so here we go. So what is DynamoDB? It's a NoSQL database in the cloud hosted by Amazon, and all the data is stored on SSDs. So it's very fast. There's no limit on how big. Well, I guess the limit is how much data Amazon can store, but for all intents and purposes, there's no limit there. And you pay for the performance you want. How much data you want to put in, how much data you want to put out, and the performance bandwidth of that. I'm not going to demonstrate the auto scaling aspect, but you can use something called dynamic DynamoDB, which will pay for, which you can have it automatically scale up and down to give you the performance you require. But keeps your prices down. And of course, as is with Amazon, Amazon has Hadoop integration directly with DynamoDB through their Elastic MapReduce service as well. So what I'm going to do here is first, what I've done is I built a geohashing strategy to store all the data in DynamoDB, since DynamoDB itself doesn't have a hashing strategy or a spatial index. And so you'll see this is what, if you give it a polygon, that's how a polygon is geohashed. So it fits the biggest geohash squares in it can in the middle, and then around edges, it depending on how accurate you make the geohash, it generates other squares. So all those squares go into the index, and so you can see per feature there can be many index records. But again, with DynamoDB, we're not concerned with the size of the data, so we're not too worried about that. And this is what lines look like. So you can see again geohashing. This is what, last but not least, this is what images look like. So that's an image. So you can see images generally, they're nice and square, so they take fewer indexes. And of course, I'm not showing you a point, but a point takes exactly one geohash. So that's very, very simple as well. Okay, so the first thing we're going to do, and I'll show you the workspace, but I won't run it, is storing vector, raster, and LiDAR data into Amazon DynamoDB. So for the raster and the LiDAR data, the data sets themselves are copied to S3. The geohashes are calculated, and the workspace looks like this. So it's very, very simple. So load. This is what the load vector one looks like, and there's a couple of custom transformers I've built. I won't go into too much detail, but essentially I built one called a DynamoDB spatial index that can take anything, and it simply takes a number. Obviously, you have to have your Amazon credentials, how accurate you want your geohash to be, and you can specify it as accurate as you want. The more accurate, the better. You can specify a category for the data, which is a natural way to divide the data, and then the S3 bucket name where you want the S3 the data stored. So if you run it on CAD data, you can see here it is here. I'm not going to go through too much detail. The only thing to notice is that for raster and LiDAR and other objects, they're going to be stored in S3, and then the geohash is calculated using something from the store called the Geohash Approximator, which you can download, and this DynamoDB spatial index transformer will also be up there. So that's what it looks like. If I look at the actual DynamoDB tables, you'll see that here's typically what the index looks like. So you'll see I have some imagery, okay, and this is for the imagery one. And you can see here's the geohash and there's the identifier. And if I go over to the Dynamo test data, you'll see and explore that table, you will see here's the actual type of data. In many cases I link it. If it's imagery, I link to the image. If I have small raster sets like I have over here, okay, and then I'm sorry, vectors data sets, then the data is actually embedded. So you can see here's a rodent. This is an actual rodent trail here. That's what the data looks like. This is the data here. Okay, if I click on it, you'll see there's the geohash, there's that. So if I go back over here to the data, sorry, and explore that one, you'll see that here's the actual embedded data. So I have both supports for embedded data or linked data. Okay, so so that's the both of those there. So anyway, so now we'll go back and look at the next one. Okay, so that is, where are we here? That is, or here. Okay, so that's vector, raster, or LiDAR. Okay, we look at the next one, geocoded. I'm going to run this one. The next kind of thing we can store is, imagine we want to store all our geocoded geocoded images. So imagery looks exactly the same as vector. Okay, so we won't look at that. But geocoded pictures, let's take a look at that one. Okay, here it is here. And again, the only difference here is what I do is I first decode the geocoding from the imagery. I built that in a custom transformer, which again will be on the store. Very simple. I just grab the lat long index, lat long information from the the header information on the JPEG 2000. Okay, and then I pump this into the same DynamoDB indexer. Okay, and I can actually run this one. So I'll run it on one. And here's what I normally do when I build workspaces is I quite often have test and debug stuff below. So I'll run this. I'll put it in test data index here. So if we look at our my Amazon S3 here, you'll notice that I refresh this. Is the actual imagery. Okay, if it comes up. There's all the images that I loaded previously. Okay, and they're actually JPEG 2000s. So I'm going to go back here, and you're going to see after I run this, you're going to see there's going to be a geotagged guy here, geocoded picture. I'm going to run this, and it'll only take a second. Okay, be much quicker if it was actually on the cloud. Okay, so it had to upload that image to S3. And now if I go back here to S3 and I refresh this, you're going to see there's a geocoded image, and there's the URL, and there's the actual image there. Okay, and I can look at that if I wanted to.
So Don, in most cases, with the data, you're not actually modifying the data itself. You're basically just tagging it when you load it.
That's right, that's right. So for LiDAR, imagery, and those sorts of things, I'm generating the geohash, then I'm copying it up to S3, and then I've created a spatial index for that. For vectors, what I do is for each vector, I extract it, I store it in DynamoDB, and then I have it's embedded in most cases, unless it's a really large feature, which then I'd create a copy in S3. Yes. Does that answer the question?
And somebody was asking about... Sorry, just so quick. Somebody was asking about video. Would we have a way of storing that?
Yes, I'm going to absolutely. I'm going to talk about that next.
Okay,
talk about that next. Okay, yeah. So if we look here, this is the test data. You can see I have imagery here. If I go to the test data now, you're going to see that I actually have everything's linked, but I actually have one that is my geocoded data right here. So you'll see there's my geocoded, and you can see there's the JPEG link, because again I copied it to S3. So now we're going to go back to my next one here. So that's geocoded images. So how about storing anything? Okay, so now what I'm going to do is I'm actually going to store you can take any file, give it a location, and then it will, and then it will, I'm getting excited here, and then it will store. So that's what I'm going to do now. And so load any document or link. So I'm going to do this twice. Here's the workspace. And again, with these custom transformers, which we don't have time to go into today, they're all very, very simple. So here's, basically I have, when I go to run this, it asks me for a location in the document or path, and then I can give it a category. I do have video on here, but obviously we don't want to watch me upload that. So what I'll do is I'll just go and grab, let's say grab this, I just say copy as path. So imagine this is a video. Okay, I paste it in here. Okay, I've got to get rid of those quotes. Of course, we don't need the quotes. Okay. And now I can, in this case, it's a workspace, but I could, if I type, I could do whatever I want, because what it's going to do is just copy this file and index it at that location. So you could imagine maybe you have, you know, locations throughout the city, maybe you have recreation facilities and you have videos, pictures, or maybe you have a construction site or anything. You can associate, what this enables you to do is associate as many different document types as you want with any location. So in this case, let's call it workspace. We'll call it Don's workspace. Okay, but you could call it whatever you want. I'm going to run this, and then what's going to happen is it's going to push that to S3, generate a geohash, and write the geohash information into DynamoDB. Okay, so now if we go back to DynamoDB, well, I should wait for that to finish. Okay, I guess it is finished. Let's make sure it worked. Okay, yep, it worked. Okay, so now we go back here. So now I'm going to go back to my tables. I created test ones just so that we can see it, so because my other ones have so much data in they, so explore that. And now if we look in here, we're going to see the imagery, Don workspace right there. Okay, and you'll see the workspace was copied. It says it's linked, and the workspace was copied to Amazon S3. So if I go to S3, and I go back to here, and I refresh this, okay, there's my workspaces, and if I drill in, there's my workspace, and again, I could download that just, you know, very, very easily, because at the end of the day, if I look at properties and details, it has a URL link that I could easily, oh, I gotta select it, okay, cancel this. If I select it and say properties, you'll see that in fact there's a URL link right there that I could just, you know, click on and download. Okay, I turned off security so anybody could add that. But yeah, so that could be video. And even if you had a video with a bounding box, if you knew all that information, you could do that, because we do know there's we have worked a little bit with video that has some header information on it as an XML sidecar file, so you could use that to index all your videos. So you can also index any URI. So imagine you have a Google document or something. You could just you know, paste the whole path in there, and then you could spatially index all your Google documents as well, or your Box, you know, anything on Box or Dropbox or any of these other cloud-based services. You don't want to copy them again into the Amazon S3. So what you can do is you can just put them, you know, right in there. So if I went to, say, my Dropbox, okay, now we're going a little off where I was going to go, and I could say, you know, drill into a webinar, okay, and grab a file, say, oh, here's a file. I could, you know, share Dropbox link, okay, or copy. I want a Dropbox. Where's Dropbox? Anyway, you got the idea. I could basically go and grab any file and essentially paste it in there. So let's see, do I got anything now?
That would load the file, or would it just a link to the file?
You'll see just the link. So it's, yep, just the link. Okay. So now it knows that, hey, this is a link. So let's call this, you know, presentation.
Mm-hmm.
Now I go like this. Okay, it's going to run. Okay, there, it's going to take a second, of course. Okay, now I go over here. I go over to my S3 first of all. Let's go back to here. It's loading it. Okay. Let's get rid of that. Get rid of this. Okay. Now let's do this. Okay. What did I call it? You remember? Presentations, I think.
Yeah, it was presentations.
Oh well, I did something wrong.
So Don, you could use that to. I could use that to store my music collection in the cloud, or if I wanted to.
Yeah, that's right. So what do we do here? So let's just HTTP, and I'll figure what I did wrong there. www.safe.com presentation. Okay, so fine. Let's try that again. So yeah. So yeah, you could do absolutely anything, and I'll check that other one, see how I messed it up later. But that's what happens when you off the road sometimes. So now let's go here, and
maybe it just takes a while to sync up.
Oh, I know. No. What am I doing? I shouldn't be looking on S3. Of course, I didn't copy it to S3. Sorry, that's not. The thing's working perfectly. It's me. I got to go to the test data index, right? Because of course we didn't or test data, because we didn't actually copy it. That was the whole point. But if we look here, we can see there's the HTTP one, and it's under there, and the other one was going to be anyway. Here it is here.
Dropbox, yeah.
Here. Yep, there you go. There's the Dropbox one. And again, it's spatially indexed, so we know where it is, but rather than copy it down, we just use the existing document, and then of course as that document's updated, it's all done. So yeah, so there you go. So so with this technique, we can store anything. We can store vector raster LiDAR, in which we copy it up. We can store geocoded images, again copying the image to S3. We can copy any document, video, music, Word, you name it, any document at all. We're just copying it up. So we're actually not even having to know what's inside that package. It could be a zip file, it could be anything associating with an index. And last but not least, any internet resource. And of course, nothing's good if you can't actually get that data out. So we'll do that quickly. Okay, here. Okay, so I have a workspace here. And go here, and of course you got to read it. And again, this is a very, very simple workspace. What I did is I wrote a DynamoDB querier, which again we will make available to people. And I run this guy, and while he's running, he takes a couple seconds, and about 35, I think. We'll go through the rest of the slides, and we'll come back and I'll show you how that works. So slideshow from current slide. And so I think it's time for our last question, Dean. What data types are you planning to store in big data? So you want to launch that?
Sure.
Okay. So
just a second here.
Here we go. Okay. So okay. So data. What big data technology are you? Okay. So data loading is the big one. High-speed query, processing analysis, high-speed data streams, and yeah. And we didn't talk about it, but one of the things we're planning for 2015 as well is support for Kinesis, and again, that's a big high-speed data stream from Amazon, and so we're going to be working with FME again. Reading and writing to that, so that's very good. Okay, so there you go.
A lot of people doing loading. Yeah, no, I'm just saying. I noticed a lot of people. Yeah. Yeah,
and of course that's the way you get started. So, while I'm running from my laptop here with FME Cloud, you could just have many things spun up, or you can. Nice thing about DynamoDB is you can be loading from many different locations, and Amazon manages to keep it all in sync and eventually it's i.e. a few seconds, everybody would see everything. So yeah, so we have a few dates coming up here. We have a webinar on how to automate practically anything with FME Server. So that's a big one about talking all about the word automate and how FME Server fits into that. How to load data into Google Maps engine. So that's a new product from Google. And of course, one of the challenges there is first getting data into Google Maps engine. So we're going to address that. On the World Tour, we would love you to join us for the World Tour. There's many, many cities, and you go to our website, you can see where they are around the world. And last but certainly not least is the FME International User Conference in Vancouver. where we're going to talk about anything FME. So we're expecting hundreds of people. Well, actually, hundreds of people have already registered. So please join us for that. We do not do this every year. We do this about every 5 years. The last one was in 2009, just before the Olympics. And so this one is in Vancouver. So with that, let's go back to that demo and have a look. It should be finished running now. And is that the query one? Yep.
Yeah.
And so what I did is I ran it. It took 45 seconds. You can see FME took 2.7 seconds. And most of it is slinging data back and forth between DynamoDB and my system, because my DynamoDB spatial query actually hits the DynamoDB database twice, and so there's a number of records flying around. But anyway, we'll scroll up and you'll see what comes back. I'll click on one, and I grab the imagery. So we didn't show loading the imagery, but for this particular query image, if I click on it, you can see because the images was loaded in DS3, the query gives us back the link to the image. So again, I can click on that, or I could directly look at that with FME or anything else. So I'll just say open with FME. Nope, not Workbench, Data Inspector. I'll just pick one. And you'll see the image is identified as JPEG 2000, of course, because it had the extension. FME can directly read from HTTP. And so here it comes, and it's coming. There it is. And if I zoom out, you'll even see that it actually lines up with the things on the ground. So you can see the streets in that area, and there you go. So it all fits. And so that image was loaded into Amazon DynamoDB and S3, and it's completely accessible to anybody wherever they are. So okay. So
cool.
Yep, and just yep. So and so also some courses, online courses. All our online courses at SAFE are free, but they are instructor led. So so you can take them as many times as you want or as you need be, and we have well, we should have updated the date on that. Anyway, they're going on all the time, and so please take a look at our website, and there's many courses. There's on-demand courses as well as recorded courses. So, and yeah, many things in the community. And there you go. So what we've tried to nail down today is to just show you some of the things we're working on with big data. It opens up a whole new world of possibilities and opportunities and challenges and problems that can be solved. And FME is great for working with this big data. We've shown a couple of approaches here. And as far as the cloud is a natural fit for big data. Without the cloud, only organizations with deep pockets who are able to afford the infrastructure of an on-premise solution could even get started. There's no way in a million years that my demo would have been able to be built, and I would be able to say, hey, this solution can store as much data as you want, because at SAFE we just don't have the infrastructure either. And last but not least, this definitely is just the beginning with more to come for sure. So yeah. So
yeah, and I'll just mention, Don, quick that one thing to touch on with FME and when we load data, it's not just about providing a single position, but we can do some value added. We can do a B-box accumulator so that you're actually loading information about the extents of the data. You can absolutely. We can do many things. I mean, that's the beauty of FME is, what do you want to do with the data? The challenge of the demos here is to come up with something simple enough that is easier to understand, but also can show you the possibilities. But yeah, you do crazy cool stuff that we'll see for sure at the user conference. Many of the things our users do is just mind-boggling. So yeah. So I think now we want to go to a chat. So we'll turn on it. We'll hide this. We'll get rid of the slides because I think that's it. Yep. And then we'll just we're going to talk. So if you want to get in touch with us anytime, there's our contact information, and please don't hesitate to contact any of us about big data, FME, or any other topic that you would like to discuss. So, and we definitely want to hear from you about what your priorities are in terms of what you see coming on your roadmap down the road. So we always take our user feedback into account when we prioritize development. And so yeah, please don't be shy and send us your questions and your suggestions about what you're looking for.
Yeah. So if anybody has questions now, I just turned on my webcam again. Please just raise your hand, and we'll try to, and what we'll do is we'll put you on the air so that everybody will be able to hear you, and then we can chit-chat a bit about what we're doing with big data and things like that. If you don't have a question or you want to do them via email or other, that's fine too. Yeah. So thanks, Dean. It's always great while we're waiting for questions. Yeah, it's thanks for putting the MarkLogic stuff together, and it's very, very exciting.
Yeah, it was a lot of fun. Yeah, and that was really cool, Don, to see how you can slog almost anything into DynamoDB or a link to it. So that's very cool.
Yeah, we have a question here from Joy about how does FME handle bathymetric data. So, you want to talk a bit about that, Dean? Bathymetry?
Sure. Well, we can handle S57. So that's our. I guess that's one of the nautical formats for marine data. Depends exactly what type of bathymetric, because you could have benthic data about the bottom of the ocean might simply be a DEM, so that could be raster or point data. It could even be point cloud. So FME can pretty much handle.
Who are some of the big people? Yeah, who are some of the big people who use our data? Like NOAA uses our FME for bathymetry. Who else is it? Does anyone else come to mind?
Yeah, I'm sure. I'm sure the Canadian
office, I think too.
Yeah, the Canadian Hydrographic, UK Hydrographic. So there's a lot of big agencies around the world that are using our stuff for storing benthic data, and I'm sure, oil and gas and whatnot as well. Yeah.
Yeah. Good. Okay. And UTech survey. I haven't heard of UTech survey, but we'll definitely look into that and see if they're a user. And so no, that's great. So it doesn't look like we're having anybody raise their hand, Dean, but we have some questions coming in. So anyway, we want to thank. We don't want to go too far over time here. It's always Dean and I could go on for days, and but I just want to thank everybody who joined us today, and thank you so much for your time, and please do keep in touch and let us know what you would like to see with big data and FME, and yeah. So thanks also to you, Dean.
Yeah, thanks, Don. From all the way up there in northern BC. So it looks it's looking good, and yeah, I can't wait to see what we're going to be doing with big data, and what our users are going to end up doing with FME once they get a hold of both. So yeah. I look forward to seeing. What amazed me about it was. Sorry, go ahead.
Was just how easy it was to build all this. So, those slides and those workspaces took me probably on the order of, 10, 20 hours. But still, what I have now, I'm pretty excited with, and we'll get it on the store, and then we'll see what users do with it and how they extend it, and it's really just the beginning.
Well, for me, what I like to say is the first time I slogged some XML at MarkLogic, I thought for sure I had an error because I didn't get an error message, and I thought, okay, something must be really wrong.
And that never happens.
What I found out was that it actually went in. Like there was nothing to it. I just posted the data to the endpoint, and the XML went in there. So
boom. That's awesome. Okay, so with that, I guess we'll sign off and say thank you, and we'll see you next time. And please get in touch with us. We're obviously excited about this, so thank you.
Yeah, thanks from me, and I look forward to seeing you guys on the world tour. So either here in Vancouver or around the world on our various city stops. Both Don and I will be on the road show. So look forward to seeing everybody.